Welcome to Eureka Math. I'm Mr. Shankel. Going to be helping you today with Module 4, Lesson 12. Let's get started. So today we're talking about linear equations, and the linear equations that we're going to be working with are in standard form. And standard form is this: ax plus by equals c. Okay, that's standard form where a, b, and c are constants, and the x is an x variable, which is our x coordinate in an ordered pair, and y is a y variable where y is the y coordinate of an ordered pair. And once we can solve for the x value and the y value, then we will get ordered pairs, and then we can plot them on a coordinate plane. So what we're going to be working on is solving the solution by substituting a number for either x or y. So let's get started. Let's start with 0. 0 is always a good place to start. And if I put a 0 in for x, I get 0 plus y equals 3. Well, if I solve this, the 0 just goes away and I get y equals 3. So if x is 0, y is 3. Now, I can plot that on my coordinate plane. I go 0, left or right, and I go up 3. So my first point is right there. All right, let's take another one. Let's do a positive 1. If we put a 1 in for x, we get 1 plus y equals 3. And then I would subtract y from both sides. Sorry, 1 from both sides, and I get y equals 2. So if x is 1, y is 2. That's my ordered pair. 1 to the right, 2 up. So I have a point there. Let's do 2. If x is 2. If x is 2, we get 2 plus y equals 3. And then we would subtract 2 from both sides and get y equals 1. So if x is 2, y is 1. That's 2 to the right and 1 up. So I get that point there. And now it's always good to get an idea of what would happen if our variable is a negative. So I'm just going to go to negative 1. If I put a negative 1 in for x, I get negative 1 plus y equals 3. And I would add 1 to both sides in this case to get y isolated. So if x is negative 1, y is 4. So that would be left 1 and up 4. That puts me right here. And then finally a negative 2. Negative 2 in for x, I get negative 2 plus y equals 3. And I add 2 to both sides, I get y equals 5. So left 2, up 5 is my final point. And you can see that we have a line. Let's draw that in. From here, it would go right through. Well, it was a poor choice of colors, huh? Anyway, you get the idea. We've got your line that goes right through all of the points, and it's straight. All right, let's try number 2. This time our equation is 2x minus y equals 10. That is standard form, where a, remember, it's let me get my pen. ax plus by equals c. So a in this case is a 2. And b in this case would be a negative 1. There would be a negative 1 right there. And c is 10. And then we still have our x and the y. So that is definitely standard form. And now we just choose a number for x or y. We could do either one. Let's just stick with x. Let's put a 0 in for x. If x is 0, we get 2 times 0 minus y equals 10. So let me do that down here. Well, 2 times 0 is 0, so I just get negative y is equal to 10. And then I don't care what negative y is. I want to know what positive y is. So remember, there's a coefficient in front of y. It's a negative 1. So I would multiply by the reciprocal of negative 1. Well, that's a negative 1 over 1. And that means that my negative times negative makes it a positive, and the 1's cancel, and I get y equals, and multiply the other side by a negative 1 over 1, and that changes my answer to negative 10. So y is negative 10 if x is 0. Okay, let's try 1. We get 2 times 1. Oops, let me back that up. 2 times 1 minus y equals 10. Okay, so 2 times 1 is 2, so we have 2 minus y equals 10. Subtract 2 from both sides. We get negative y equals 8. And then hopefully you'll see that when we have a negative y, we can just say, well, if I change my y to positive, then my answer is going to change to its opposite as well, which makes it negative 8. So when x is 1, y is negative 8. What about when x is 2? Well, that's 2 times 2 minus y equals 10. Okay, 2 times 2 is 4, so we have 4 minus y equals 10. Subtract 4 from both sides, and we get a negative y equals 6. A positive y then would equal negative 6. So if x is 2, y would have to be a negative 6. How about a negative 1 for x? 2 times negative 1 minus y equals 10. 2 times negative 1 is a negative 2, so we have negative 2 minus y equals 10. We'd have to add 2 to both sides this time. That gives me negative y equals 12, and that means a positive y would be negative 12. So if x is negative 1, y would be a negative 12. And then finally, if we have a negative 2, let me erase a little bit so I have some room. Let's go over here. Let's see, it would be 2 times a negative 2 minus y equals 10. And 2 times negative 2 is negative 4 minus y equals 10. We would have to add 4 to both sides to isolate the variable. That gives us negative y equals 14, so positive y would equal negative 14. Negative 14 for y. And then we can plot the points. Looks like I'm gonna keep my x-axis counting by 1. So 1, 2, 3, 4. This would be a 5. And that will make sure that all of my numbers get on the coordinate plane. This here would be a negative 5. And I'm going to count by 2's on the y value. So 2, 4, 6, 8. 10 would be here, right there. And then negative 10 would be right here. And we can plot our points now. 0, negative 10. 0 left or right. But go down 10 would be that point. 1 to the right and 8 down would be here. 2 to the right and 6 down is here. 1 left and 12 down, 1 left, 12 down would be here. And 2 left, 14 down, 2 left, 14 down would be there. And there's our line. Let's see if we can draw a better color here. So my line would be right here. Oop. There we go. So there's our line, linear equation from the standard form. Okay, number 3, x plus 5y equals 21. This time I'm going to substitute for y. Since my y has a coefficient, I'm going to put some numbers in for y. And let's say if y is 0, if y is 0, then we get x plus 5 times 0 is equal to 21. And that would give us 5 times 0 is 0, so x is 21. Okay, if y is 1, then we'd have x plus 5 times 1 equals 21. So x plus 5 equals 21. And then we would subtract 5 from both sides to isolate the variable. We get x equals 16. So if y is 1, x equals 16. Let's check if y is 2. Well, we'd have x plus 5 times 2 equals 21. 5 times 2 is 10, so x plus 10 equals 21. Subtract 10 from both sides, and we get x equals 11. So if y is 2, x is 11. And we just really need to check some negatives, so let's put a negative 1 in there. X plus 5 times a negative 1 equals 21. That gives us x plus negative 5. So I'm just going to make that negative. X minus 5 equals 21. We would have to add 5 to both sides. And that gives us x equals 26. Okay, and then if y is a negative 2, we would have x plus 5 times negative 2 equals 21. And that is x minus 10 equals 21. We'd have to add 10 to both sides, and that gives us x equals 31. So there we have it. We have x values and y values, and those are our coordinates. So we can now plot those on the coordinate plane. Let's see. I've got 1, 2, 3, 4, 5, 6, 7, 8. I have 10. I'm going to need to count by threes on the x-axis. 3, 6, 9, 12. This one would be 15. And if we go the other way, this would be a negative 15. And I only need to get to 1 and negative 2 on my, 2 and negative 2 on my y-axis. So I can really make a positive 1 here. That puts 2 at the end. And I could put negative 1, 5 down as well. So this would be a negative 1. Okay, so now we can plot our points. And it's just ordered pairs. 21 to the right, 0 up. Well, 21 to the right would be, let's see, this 15 is here. This would be 18, 21 right there. So 21 to the right, 0 up. That's my point, 21, 0. 16 to the right, well, 16 is a little bit bigger than 15, and then 1 up. 16 to the right and 1 up would be about right there. Okay, 11 to the right and 2 up. Well, 11 would be just below this line. So, and then up to 2 would be right up at the top. So my point's going to be around there. 26 to the right and 1 down. 15, 18, 21, 23, 26 to the right, and then down 1 is going to be here. And I'm not going to be able to fit my other one on there, but you can see the line. The line goes right through all of those points. Let me get it to straighten up. There we go. So there's my line from the standard form, x plus 5y equals 21. Let's do another one. 2/5 x plus y equals 11. This time the coefficient is on x. So I'm going to choose x. Let's make x 0. If x is 0, I get 2/5 times 0 plus y equals 11. And that's 0 plus y equals 11, so y equals 11, that's it. If x is 0, y is 11. If we put a 1 in for x, 2/5 times 1 plus y equals 11. And that gives us 2/5 plus y, 2/5 plus y equals 11. And then I need to subtract 2/5. Well, in order to do that, I need to change my 11 into fifths. So if I multiply the numerator and denominator by 5, I get 55 fifths. That's the same as 11. 55 fifths minus 2 would be 53 fifths. So y equals 53 fifths. That is the same as 10 and 3 fifths. So I'm going to use 10 and 3 fifths here as my y value. If I put a 2 in, we get 2/5 times 2 plus y equals 11. And that's 4/5. So 4/5 plus y equals 55/5. And then subtract 4/5 from both sides. And we get y equals 51/5, which would be 10 and 1/5. So if x is 2, y is 10 and 1/5. And then let's check some negatives. If we have a -1, this would be 2/5 times -1 plus y equals 11. -2/5 plus y equals 55/5. And then this time we have to add 2/5 to both sides. Add 2/5, and we get y equals 57/5. So that's going to be 11 and 2/5. That's 11 and 2/5. And then if we add a -2, I'm going to make myself some more room over here. If we had a -2, we would have 2/5 times -2 plus y equals 11. And that's a -4/5, so -4/5 plus y equals 11. Add 4/5 to both sides. And, well, remember, this is 55/5. Almost forgot that. And then we get y equals 59/5. That's 11 and 4/5. So 11 and 4/5 is my last answer here. Okay, now we need to plot these. So on my x value, I'm gonna put a 1 here. This is 1. That means 2 is out here. And on the left side, 5 to the left would be a -1. 10 to the left would be the -2. That would be out here. And on my y value, I just need to get to 12. So I'm gonna count by, I don't know, 2, 4, 6, 8, 10, 12. That works. Or I could go 3. Yeah, let's just count by 2s. So 2, 4, 6, 8. This is 10. And -10 would be here. And the next would be -12. So -12 would be right here. So all of our answers on the y value are going to be between the 10 and the 12. But here we go. Let's plot them and see what we get. X is 0, y is 11. X0, y11 is halfway in between the 10 and the 12. X is 1, y is 10 and 3/5. X is 1, y is 10 and 3/5 is not quite to 11, so it's a little bit below, so maybe right in there. 2 and 1/5, that's barely above 10, so about there. -1 and a positive 11 and 2/5 is a little bit higher, so about there, And a -2 and a positive 11 and 4/5. 11 and 4/5 is almost 12, so it's right at the top. And then let's check our line. It should be really close to lining up. Yeah, there they are. So there it is. That's your line from the equation 2/5 x plus y equals 11. Hopefully you're noticing that all these linear equations produce a unique line where all of the points are on that line. Okay, number 5. At the store, you see that you can buy a bag of candy for $2 and a drink for $1. Assume you have a total of $35 to spend. You're feeling generous and want to buy some snacks for you and your friends. Write an equation in standard form to represent the number of bags of candy, x. So my bags of candy is going to be my x value. And I'll draw x value. And the number of drinks is the y value. So this is going to be my y value. Okay, so it's $2 for every bag of candy. That's 2. Let me put it up at the top. That's 2x plus, it's $1 for every drink, so that's plus y. and I have a total of $35 to spend. So there's my equation in standard form, ax plus by equals c. And now we're just going to do the same. I'm going to choose a 0, a 1, a 2, a -1, and a -2. And I'm going to plug those values in for x and find out what y is. If I put a 0 in for x, 2 times 0 plus y equals 35. I get y equals 35. If I put a 1 in, 2 times 1 is 2 plus y equals 35. I would have to subtract 2 from both sides. That gives me 33. If x is a 2, 2 times 2 is 4 plus y equals 35. I would have to subtract 4 from both sides, so y would be 31. If I put a -1 in, let's look at that one. 2 times -1 plus y equals 35. 2 times -1 is a -2. I'd have to add 2 to both sides, so my y is a 37. And then if I put a -2 in, that's a -4 plus y equals 35. Add 4 to both sides, I get y is equal to 39. All right, and if we sketch this 0, let's put 1 here and a -1 there. -2 would be at the end, +2 at the end. And then for the y's, where they're going to be scrunched together here, 5, 10, 15, 20, 25, 30. 30 would be here. That's 30. And then 35 would be here, and then this would be 40. So let's put 40 here. Okay, so there's our coordinate plane. And then we just plot the ordered pairs. 0 to the right, 35 up. That's right there. 1 to the right, 33 up. Well, 33 is going to be somewhere in there. 2 to the right, 31 up. 2, and I got it in the wrong spot. 1 to the right, 33 up is going to be about right there. 2 to the right, 31 up is just a little bit above 30, so right in there. 1 to the left, 37 up is going to be in that area. And then 2 to the left and 39 up is almost 40, so way up there. And here's our line. That is the equation 2x plus y equals 35. All right, that is lesson 12. I hope that helps. See you again next time.